So in the last couple of lectures, we talked about what are called linear measurements. Right? Those are measuring distances, right? Doing measurements in one dimension. Well, now I want to take the next step up, right? What if we have a two-dimensional object, like this rectangle here? And I want to get an idea of its size, right? I want a way to measure something in two dimensions instead of just one. Well, here's how this works, right? It all starts with this little box right here, right? This little box is 1 unit on the side. The unit we use doesn't matter. It's going to be the same for all of them. So let's call this 1 centimeter, right? And it's 1 centimeter here. Now, the way our initial definition, the area of this one by one box is 1 square centimeter, right? You notice the 2, right? The 2 is what tells me that I'm talking about a two-dimensional measurement, an area measurement, versus just a regular linear measurement. So how can I expand this? Right now I've got this box over here, right? And I want to know what the area of this box is. Well, the area of this box is equal to the number of these little 1 by 1 boxes that I can fit into it, right? So I've got 10 boxes here on the bottom, and I've got 5 boxes here along the side, right? That means I have 10 times 5, or 50 1 centimeter square boxes each, right? So that means the area of my larger figure is 50 square centimeters. Right? So that's how we're going to define area measurements in 2 dimensions. So the next thing we want to be able to do is convert things, right? For example, I'd like to be able to convert 1 square foot into square inches. All right, what you can't do is just multiply it by 12. Right, there's 12 inches in a foot. So normally that would be our process, right? I would take my conversion factor, 12 inches per foot, multiply, out would come my answer. But look at what happens when I do that, right? If I come over here and I multiply by 12 inches per foot, look at what happens to the units, right? This feet down here in the denominator cancels with one of the 2 feet in the numerator, and I'm left with foot inches, which is just some bizarre measurement, right? Which isn't what I wanted. I wanted square inches, right? But look, here's how I'm going to fix this. I'm just going to do it again. Multiply it by a second 12 inches per foot. Now this foot cancels with this one, and all this stuff are inches, right? 1 times 12, that's 144. Inches times inches is square inches, right? And there's my conversion factor, right? 1 square foot is equal to 144 square inches. So notice the pattern here, right? I'm going from square inches to square feet, and to do square feet to square inches, and to do that I squared the conversion factor, right? 12 squared is 144. Or if you prefer to be a little more visual about it, take a look at this box over here, right? I took this 1 foot by 1 foot box and I broke it up into 12 inches here on the bottom and 12 inches here on the top, right, top to bottom. How many of these little 1 centimeter, or we're doing inches, right? How many of these 1 square inch squares do I have in here? Well, 12 times 12 is 144, right? Exactly the same thing that we got before. Okay, so I have over here a bunch of conversion factors for us to work for. And I wanted to just try one of these out, right? The process here is going to be exactly the same That's what we did before, right? So I want to know how many square feet are there in 5 square miles. So I'm going to start with 5 square miles. That's another way for me to abbreviate square miles. I could have done a little mile squared, right? That would have been fine too. Then over here, I have a conversion factor that goes from square miles to square feet. All right, so I'm going to do my same unit conversions that I did in the last couple of lessons. I know I have to have square miles down here in the bottom, so these are going to cancel, and I want to end up with square feet. So go to my conversion factor, 1 square mile, an awful lot of square feet. Let me make a little more room for myself. 27,878,400 square feet. And now you go to your calculator, 27,878,400 times 5 is going to be an awful lot, right? This is 139,392,000 square feet. Let's put some commas in here. There we go. 139,392,000 square feet in 5 square miles, right? An awful lot. Okay, so how about volume? Okay, look, volume is going to be the exact same thing, but we're going to do it in 3 dimensions instead of 2, right? If this box is 1 foot on a side, that's 12 inches, so this one will be 1 foot or 12 inches. Same thing here, right? 1 foot, 12 inches. All right, this is a 1 cubic foot box. I would say 1 cubic foot. And how many 1 cubic inch boxes? Well, if I did the same thing I did before, right, and I break it up here, and I break it up here, how many 1 cubic inch boxes are there in there? Well, it's going to be 12 times 12 times 12, which is 1,728 cubic inches. Right, but most of the time, you're already going to have these conversion factors handy, right? You have them in a chart, or you can look them up online, okay? And you're going to do the unit conversions with the exact same unit analysis that we've been doing in all the other questions. Now, measuring volume in the imperial or English system, there are a lot of very strange types of volume. There's pints versus quarts versus gallons, ounces, cubic feet, right? An awful lot of different systems. But converting back and forth between them, it's all based on this unit analysis. So I got an example here, right? I want to go from 10 cubic feet into quarts. Well, can I do that? No, I don't have a conversion factor that goes from cubic feet to quarts. But what I can do is go from cubic feet to gallons, and then go from gallons to quarts. All right, so let's do that. I'm going to do cubic feet on the bottom, gallons on the top. So 1 cubic foot is 7.48 gallons. All right, that gets me to gallons, right? Now I'm going to use my other conversion factor. I have to put gallons on the bottom so that they cancel. And I'm going to put quarts on the top. 4 quarts to 1 gallon. Now you get your calculator out. 10 times 7.48 times 4 is 299.2 quarts. Right? Exactly the same kind of process we've been doing with all of our other conversions. All right, so we're talking about the metric system. We already saw that the base unit for length is the meter. Right, well, the base unit for volume is the liter, which is abbreviated with letter L. Sometimes you'll see a lowercase l as well, right? So there's a very simple conversion factor between the liter type of measurement and the cubic type of measurement that we've seen so far, right? 1 milliliter is equal to 1 cubic centimeter. So my question now is, how many cubic centimeters are there in 1 liter? Okay, well, I need a conversion factor, right, to do this. And specifically, I need a conversion factor that takes me from cubic centimeters to liters. Okay, so really, let's take this milliliter number. How many liters is 1 milliliter? Remember how we do this, right? I've got liters, deciliters, centiliters, and milliliters. So if we go from milliliters to liters, I'm going to move the decimal point 3 places to the left. So if I do that, this becomes 0.001 liters. Okay, and that's what I need, right? I've got 1 liter. I'll use the capital L. 1 liter. And I know that there is 1 cubic centimeter in 0.001 liters. So the liters cancel. And I have 1 divided by 0.001. That's 1,000. Check with your calculator. So 1 liter equals 1,000 cubic centimeters, right? And there's our answer. So that ends our discussion of area and volume, right? Measurements of capacity, right? The sizes of things. So we've got 2 more topics to talk about. In the next section, we're going to talk about the third kind of base unit. We're going to talk about measurements of mass or weight. There's a distinction there, but we'll talk about that when we get into the lecture.